Hi everyone. Hope you can hear me well. Can someone please ping me on Zoom chat? Okay, great. Okay. Thank you very much for joining. Hope all of you are doing good and staying safe. I'm Prabhas Srivadana. Sorry, I'm Prabhas Srivadana from WSO2. If you hear about WSO2 for the first time, it's a company that produces a set of open source products. We have an identity and access manager, that's the WSO2 identity server, and that's the product which I lead. We also have an API manager and an enterprise integrator, all released under open source Apache 2.0 license. A couple of housekeeping items before we start. All of you are muted now. In case if you have any questions, please feel free to unmute and speak up, or else you can use the Zoom chat to raise any questions. So this is our third meetup. We started this IAM for developer meetup group and plan to do a session every week. So this is our third week. And next week, we are planning to do a session on securing single page apps with OAuth 2.0. Okay. So before we get into the topic, just to set the expectations right, I won't expect you to have a deeper understanding of OAuth 2.0. Maybe you heard of OAuth 2.0, use OAuth 2.0, that's enough. We'll start with basics and then go to internals, and then we'll see what are the applications of OAuth 2.0. Any point, if you have any questions, please feel free to raise. Okay. So what you see in the slide, I won't expect you to read. So this is exactly like copied from the OAuth 2 RFC. OAuth 2 is an RFC standard developed under the OAuth working group under IETF. So the takeaway from this slide is OAuth is an authorization framework for access delegation. That's the simplest definition of OAuth 2.0. So then again, being a framework, so there's a challenge. So when we use a framework to do something, so we have so many options. Then it's up to us to pick whatever the best options that will suit our requirements. So that's the challenge in using OAuth 2.0. So there are multiple profiles built around OAuth 2.0, like for example, under a FAPI working group, it defines what are the best practices for financial APIs. And there are multiple security profiles defining best practices. So there are things going on to help people understand OAuth 2.0 better, and then so they can make more informed decisions when they use OAuth 2.0. Okay. So the bottom line is it's an authorization framework which does access delegation. In OAuth, we have four main actors: a client, an authorization server, a resource server, and a resource owner. So let me use a practical example. Let's say you have an Instagram account and you want to publish your Instagram photos from Instagram to Facebook, right? So Instagram application is the OAuth client. Facebook plays dual roles here. Facebook is also the authorization server, and also is also the, one second. Okay. Facebook is also the authorization server and the resource server. So it's playing dual roles here. Then resource owner is you who own the Facebook account. Now, if you want Instagram to access your Facebook wall, then you need to give some temporary token to Instagram client. So the Instagram client can use the Facebook API and publish photos to your account, right? So the way it works is if Instagram wants to access your Facebook API on behalf of you, Instagram will redirect you to the Facebook authorization server. So there you will authenticate to Facebook. You won't share your credentials with Instagram, but only with Facebook. And tell Facebook it's okay to share a token with Instagram just for a limited period, only to publish photos to your Facebook wall. It won't be able to read your friend list. Instagram won't be able to see your Facebook chats or do anything else. Just publish photos to your Facebook wall. So then, if you give your consent to Facebook, the authorization server, it will issue a token to the OAuth client. Then Instagram, the OAuth client, will use that token to access the Facebook API, in this case, Facebook API as a resource server to publish photos. So now along with the API, you send the token you got from the Facebook authorization server. Then the resource server or the Facebook API will intercept the request, capture the token, will talk to the token issuer, once again, it's the Facebook itself, see whether it's this particular request is allowed to perform that action. If it is so, then you will let Instagram publish photos to your Facebook wall. So in this case, it's the Instagram client who is accessing your Facebook APIs on behalf of you. So that's the access delegation we talk under OAuth 2.0. Okay, so that's at a high level how OAuth works. Okay. Now, so there are multiple ways you can get a token from the authorization server to access a resource in a resource server, right? So these ways, these multiple ways are defined in OAuth 2.0 under something called a grant type, or else better to say grant flows. So OAuth 2.0 core specification defines 4 main grant flows. The most used one is the authorization code grant flow. Okay, so if you take like 95% of the OAuth deployments you see in practice today, they use authorization code grant flow, which uses authorization grant type internally. Okay, so let's see how this works. So you have the OAuth client. Now, when you want to give this particular OAuth client access to a resource that you own, the OAuth client will first redirect you to the authorization server, right? So once you get redirected, OAuth client also inform the authorization server, I need a token for this particular purpose, right? In the Instagram example, the purpose is to publish photos to your Facebook wall. Then authorization server first will identify the client. So client has to be known to the authorization server first. If it's a known client, then it will ask from the resource owner whether it's okay to approve that request. So you need to give your consent to the authorization server. Then once that is done, authorization server will redirect you back to the OAuth client. That's another 302 with something called authorization code, right? So authorization code is a temporary code. It has a very limited time lifetime. It's around like 30 seconds to 1 minute, right? And it's a one-time code. Now the client application gets the code, right? So the code once again is visible to the end user. So client application gets the code and then it will talk to the OAuth token API directly. It's a direct call. It doesn't go through the browser. So that any parameters in that request is not visible to the end user, right? So in step 4, you exchange the client application exchanges the authorization code it got from the authorization server to an access token, right? So you get an access token. Now you can use this access token to access the resources that you own, right? So then once again, when you get the access token at the resource server level, it will extract out the access token from the request and then we'll talk to authorization server and validate the token, right? So that's the basic flow. Now, if you go to a little bit of detail here, right, there's a sequence diagram that explains the same scenario we discussed in the previous slide. So you have the browser, the client application, then the authorization server, right? So once again, if you go back to the previous one, the grant type only talks about steps from 1 to 5. It doesn't talk about step 6, right? So most of the cases, step 6 is common across all the grant types. So once you have the access token, in step 5, you can use it against an authorization server. Grant types don't talk about step 6, how you do it, okay? Here, you have the browser. So browser will do a get to the client first. Then the client will redirect. So it's a 302, right? So something to understand here is instead of 302, it goes to the browser. So basically client sends a 302 to the browser and browser will do a get to the authorization server. It flows to the browser and then it goes to the authorization server. Then authorization server will check whether this particular user has a valid session. If not, it will send it 200. So this could be the login page and also the consent page. So once that is done, you post that response from the browser to the authorization server. Authorization server will generate a code and then again we'll do a 302, right? So basically you send here and the callback URL, a URL pointing to the client will be set as the location header of this response. Okay, the 302 location header is set to the client. So it goes to the browser, then browser will do a get to the location header. Now the code goes to the client. Right? So now client has a code, then client will use that code to access the authorization server's token endpoint and get an access token, right? So this first request, this authorization request goes to an endpoint called authorized endpoint in the authorization server. The token request goes to the token endpoint. So what is in the green box, that request flow initiate from the authorized endpoint. What's in blue box, that flow starts with the token endpoint, right? So there are two main endpoints, authorized endpoint and token endpoint, okay? So let's look at some of the parameters in the request. So when you do a redirect here, you need to send something called response type parameter. And if you are using authorization code, the value of the response type must be set to code, right? So you only send the response type parameter to the authorized endpoint. You never send the response type parameter to the token endpoint. So you will realize that when we discuss other grant types too, right? So response type is an indicator to the authorized endpoint of the authorization server on how it has to form the response, or else what tokens it has to include in the response. So here when we set the response type to code, that means authorization server should send back a code to the client application, right? So that's called response type. And if you look at OpenID Connect spec, so OpenID connects an application of OAuth 2.0. It also defines another parameter called response mode, right? So response type defines what tokens you get. Response mode defines how you get those tokens, right? So the authorization server can send those tokens as query parameters. They can send those the tokens as URI fragments, or else in a form post, right? So likewise, how you get those parameters are defined in the response mode. How you get what you get from the authorization endpoint is defined by the response type. So in OAuth flows, we only talk about response type, and a given response type has its own response mode defined too. So in this case, you get the authorization code as a query parameter. Okay, so that's how the authorization code works. And there are a couple of other parameters, a couple of important parameters like scope and state. So we'll discuss those stuff later on. Okay, so let's see a demo. Now to demo, I'm using identity server. It's an open source identity server. You can use any open source IDP. So identity server is acting as the authorization server here. So I'll log in here. And now I need to create an OAuth client, right? So in identity server, we identify an OAuth client as a service provider. So you can add a service provider here. I already have done that. So I'll show the configuration. So this is curl app is my OAuth client application. I'll show its properties. So now under inbound authentication configuration, so identity server supports multiple protocols, SAML, OpenID Connect, WS Federation, likewise. Since we are using OpenID Connect here, let's expand this configuration and click on edit. So here I have picked all these grant types. So based on your application, you can pick which grant type you want to pick. So here I have enabled all the grant types. In the demo, I'm going to show you how the authorization code grant type works. Then I also need to specify the callback URL, right? So if you look at the diagram, the authorization code here is sent to this callback URL from the authorization server. Okay. So I have set a callback URL that does not exist. There's no application running under this particular callback URL. So you will see like entire message flow in its like raw format, right? So that's it. The other stuff are like some other details. You can change the access token lifetime, ID token lifetime, refresh token lifetime. So that's basically like out of the OAuth specification. It's up to the authorization server to implement these features in the way they want. Okay? So now I need to know the client ID and the client secret of this application, right? So the application is identified at the authorization server by the client ID and the client secret. Okay? So I need to copy them, and then I have an environment sh file. So I'm going to use a curl command here. So I have already put my client ID and client secret, right? And these are the endpoints. So this is the token endpoint of the identity server, and this is the authorized endpoint of the identity server. Okay? So first, let's source the environment sh file. Okay. Now we need to construct. So I'm not using a web app to demonstrate the flow. I'm just using like a curl here. So now let's say you are on Instagram and click on login, right? So then Instagram has to generate a request, okay, which will redirect to the authorization server. So now I am going to generate that request in my curl command. Sorry. Okay. So this is the URL. You will get redirected when you click login on Instagram, right? So here you can see authorized endpoint. This points to the identity server, and client ID, and then scope. We'll talk about scopes later, and the redirect URI, which points to a URL that's under the control of this particular application. And since we are using authorization code, the response type must be code, right? So let's copy this URL. And then, so I'll use private browser. So now, so once I type this one, I get redirected to the identity server login page. So I don't have login session. So I am prompted to enter my username and password. Let's log in with Peter, bin123. And now I got redirected to the callback URL, right? So here you can see authorization code, right? So in Instagram, if you follow a real application, then you will get this response to the application itself. Then application code has to extract out this authorization code, right? So now I extracted out the authorization code. So I need to export this to my environment. Then I can do a request to the token endpoint, right? So if you look at the diagram here, right, we are here now, right? So we got the authorization code from the authorization server. Now we are ready to do the number 4, exchange this authorization code to get an access token, right? So in this step, the client is going to authenticate to the authorization server. But once again, the client authentication to the authorization server is not a must, right? It's optional. You can use it or else you can ignore it. So in this case, I'm going to use client ID and client secret to authenticate the OAuth client to the authorization server. And this is that curl command. Right? So if you look at this curl command, yeah. So here I am sending client ID and client secret. So these are picked from my environment sh file. Then code has to be set to the authorization code that I got from the first response. Then grant type has to be authorization code grant type, right? So response type parameter always goes to the authorized endpoint. Grant type parameter always goes to the token endpoint, right? Now you need to send the client ID to, and once again redirect URI. So this redirect URI should be the same redirect URI we sent in the initial request to the authorized endpoint. And here this is the token endpoint, right? So let's execute this command. Now you can see I got an access token, refresh token, and though that the access token is issued under this particular scope, right? So this is the scope we requested in our first call to the authorized endpoint, right? So scope defines the purpose of this access token. I need this access token to perform this particular action, right? So whatever the value in the scope parameter, it's a simple string, both the authorization server and resource server should know how to interpret the value of the scope, right? So if you want to publish photos from Instagram to Facebook, then you may request scope as published photos, right? So that's just a string. Then the resource server, the Facebook API should know if there's a token, access token with the publish photo scope attached to it, then you should let them do a post or a put to the Facebook wall to update or add photos, right? So the value of scope, the string value, the value of the scope string should be interpreted by both the authorization server and the resource server. Another thing to highlight, when the access token is issued from the authorization server to the client, authorization server can also do an access control check to see whether this particular user is authorized to issue a token to this particular application under this scope, right? So you can do those access control checks too, like the client application won't be able to get a token to any scope it wishes, right? So authorization server has the complete control over what token they can issue, they want to issue to a client application under which scopes, okay? Yeah, so there's a question asking, expires in 1 hour, how does the client know when the hour starts? Yes. So basically, this is an indication, right? This is an indication saying this client, this particular token will expire in this particular seconds, right? This is in seconds, right? So this is just an indication. So there are a couple of approaches for the client application to find out whether token is expired or not. The first one approach is before the client application uses the access token, it can also check, it can all the time check whether the access token is expired or not, right? So this expires in time is just a guideline, right? The other approach is you can simply ignore what's in the expires value and talk to the resource server, and if sends a response back saying it's expired, then it can go to the authorized server and renew the access token, right? So if you want to refresh the access token without getting the end user's consent again, then you can use refresh token. So there is no browser flow. You can just use a refresh token and get a new access token, right? And also, it's not a must to issue the refresh token all the time, even with authorization code grant type. It can be some out of band configuration you set up at the authorization server side. Okay, so there's another question. How to authorization server can control which scopes can be requested by specific client? How token endpoint can cross-verify this token issues to the specific scopes? Okay, yeah. Now the scopes supported by the authorization server should be known to the client application first, right? So you develop an application and you know which APIs you are going to consume from your application. Then from the API side, you specify if you want to consume this API, if you want to do a get to this API, or if you want to do a post to this API, these are the scopes you should bring in, right? So whatever the token you use to access or perform these actions on these resources, those tokens should have this particular scope. So those should be predefined. So most of the API documentations, if you look at, so those are documented. So when you develop a client knows what are the APIs it wants to access, then it will also know what are the scopes required to access those APIs, right? Then again, you can request those scopes from the authorization server. So authorization server should know how to authorize the user based on a scope, right? So there are multiple ways you can do that. So one is at the authorization server side, you can bind a user role to a one or more scope, right? So whenever you request a scope, authorization server checks whether this particular user is in this particular role who can issue a token under this particular scope. That's a straightforward way. Or else you can attach a policy, authorization policy by scope. So whenever someone requests a scope, the authorization server will evaluate a policy and see whether this particular person, the user, can issue a token under that particular scope. Okay? So I hope, Sudhir, I answered your question. Okay. Now let's see a real example. Let's see how Instagram actually works. Okay. So let me bring in Instagram on a private browser. Okay. So this is the Instagram login page. Okay. So now I will start the developer tools. So now we can see the entire flow. So now I want to log into Instagram using my Facebook credentials. So let me click on login with Facebook. Right? So this will generate a request which will be sent to the authorized endpoint of Facebook. This is exactly what we did with Curve, right? Okay. This should take me to the Facebook. Okay, now I'm on Facebook login page. Okay. Now, if you look at this flow, have a look at this request. Right? So have a look at this request. So this is the request going to the authorized endpoint of Facebook. Right? So let me copy this one. And paste it somewhere else. Okay, so now if you look at this one, you can see you are sending the client ID. So then Facebook knows this is the Instagram who is sending this request. Redirect URI, this is a URL pointing to the Instagram. So when Facebook sending back the authorization code, it will send to this particular URL. One thing to notice, so this URL should be pre-registered as the Facebook site, right? So when you get this redirect URI in the request, Facebook will check whether this is the same URL the Instagram app registered at the Facebook end. Otherwise, it will simply reject the request. Once again, it's up to the authorization server implementation how it uses the validation logic, right? So it can do a string one-to-one match between the redirect URI which is coming the request and the redirect URI what is registered in Facebook, right? It can do a one-to-one mapping, or else you can do a regex validation too, right? But whatever the approach you pick, you need to pick it very consciously. So now you have the redirect URI, and then you have state parameter. So we'll talk about state later. And then you have scope. And now you have the parameter called response type, right? So this is authorization code grant type. You can see response type is set to code, right? Scope email means Instagram wants to know my email address, or the scope, the value of scope should be interpreted in the same way the Instagram interprets, right? Both the Facebook and Instagram should interpret the value of email in the same way, right? So you will get set of attributes when you send email as a scope from Facebook. Then state we'll talk about later. One thing to notice is response type is set to code here, but it also set something in addition to code, right? This is granted scopes, right? So this response type is not defined in the OAuth specification. So this is something custom Instagram has come up with. But once again, response type is an extension point in OAuth, right? So why we use response type is to request some tokens from the authorized server, right? Looking at the response type, authorized server knows which tokens to return, right? So now we are here. So let me take this to the other monitor and log in. So I'll log in here, my credentials, and I also need to use my POTP. Okay. Okay, so now I'm logged in. So here I'm logged in, right? So I'm on Instagram now. Now, if you look at the code here, I'll copy this once again. Here you can see, it's the same thing. This is the one I need to copy. So if I paste it here, so you can see this is the callback URL of Instagram, and Facebook has sent a code, right? So this is the code, and it has a shorter explanation time. And also in the response time, we also ask for granted scopes, right? So here you can see granted scopes being sent from Facebook side. So whatever the values should be understood both by the Facebook and the client application or the Instagram. Okay. And it also has sent denied scope, right? Then also it has sent a state parameter, right? So beauty of the state parameter is if you set some value to state parameter from the OAuth client side, the authorization server must send the same state parameter back to the client application. It's a must, right? So we'll see why we use this state parameter later on. Right? Okay, so there's a question: is response mode optional or request is using default response mode for the auth response? Yeah, response mode is optional, right? So once again, response mode we mostly discuss in the OpenID Connect world. Yeah, so it's optional. So each response type has its own default response mode too. There's another question: is denied scope part of the OAuth standard? No, denied scope is also not part of the OAuth standard. It's coming from Facebook in the way it interpreted the granted scopes response type, right? So if you send a response type, the granted scope as a response type, then Facebook will send back both the granted scopes and the denied scopes to the client application. So if you look at the Facebook documentation, let me pull that. You will find that. Here. This is the Facebook documentation. Yeah, here you can see the granted scope response type it supports. Okay. Okay, so let's move on to the next slide. Here, this is called IDP mix-up attack. So this hasn't like happened in practice, but something theoretically that could happen, right? So let's go through the attack first, then we'll discuss how we can prevent. So now you have a victim, right? So this is a user of an application, and you have a client application which shows multiple login options, right? So one option can be Facebook, another option can be Twitter, likewise, right? So if you look at like Medium, for example, right? So if you go to Medium here, it would be something like this, right? You click on sign in. So you see multiple login options, right? Pointing to different IDPs. So in this particular case, this application presents multiple login options, right? So let's say one option is pointing to foo IDP, then the other option points to evil IDP. Okay. Then let's say the victim picks foo IDP, right? So I click on foo IDP. Then when request goes from the browser to the OAuth client application to the backend, in OAuth specification does not talk about this communication, right? The OAuth specification asks everyone to use TLS for all the communications, but it doesn't talk about this communication. It's not OAuth protocol, right? From here to here. It's just a post, right? Whatever the IDP you pick, right? So when you, so if let's say this is not on TLS, then the attacker can insert the request, and this option now being changed from foo IDP to evil IDP, right? So now OAuth client application thinks, okay, the user should be redirected to the evil IDP, right? So then step 3, you send a, this is another 302, right? So you send a response to the browser where you set the location header pointing to the evil IDP. Now once again, the attacker intercepts a number 32 and then change the location header to the correct IDP, foo ID, right? So now request comes here and user will redirect to the foo IDP. So that's the one the victim picked, right? So no surprise there. So the user will authenticate the foo IDP. Then foo IDP will redirect the user back to the application, sending the code, right? So now application gets a code, right? So this code was issued from the foo IDP, but still the client application thinks this code came from evil IDP, right? So because of that, the client application talk to the evil IDP's token endpoint, pass that code to exchange the token. Now, evil IDP will get hold of this authorization code, right? So if you have the authorization code and if you know the client ID and client secret, then you can exchange that to an access token. And also there are many use cases we use OAuth, mostly public clients without an client secret, just the client ID, which is public too. Then evil IDP can know it. Then once you have the code, you can exchange that to an access token, right? So this is called IDP mix-up attack. So how to prevent this? The easiest way to prevent that is, if you have multiple IDPs, multiple IDP login options, you can have different callback URLs by IDP, right? So if the authorization code comes from foo IDP, then the callback URL could be client app/foo. If the response coming from evil IDP, then the callback URL could be client app/evil, likewise, right? So how does that fix this problem? So in step 3, now the client app thinks this is coming from evil IDP, right? Now it will redirect the user to the authorization server, but in its session, in the browser session, it will say this is a redirect URL. This is going to the evil IDP, right? So now request goes here. The attacker will change the location header. So the user get redirected to the foo IDP, get the code, and come to the authorization server. But now this authorization code comes to the callback URL corresponding to the foo IDP. Now the code running there will get the authorization code and will also see whether the callback URL matches with what it added to the session, right? So what it added to the session is evil IDP's callback URL, but now you are on foo IDP's callback URL, so it will discard the authorization code, right? So that is how you can fix an IDP mix-up attack. Okay. So any questions on that? Okay. So next, let's have a look at how a cross-site request forgery attack can take place in an OAuth environment, right? So here, so you have the attacker, you have a client application, and an ID provider. So this can be a common IDP like Facebook, right? So attacker can have valid account there, and also victim can have valid account there. So what happens here is, first attacker will try to log into this OAuth application, right? And attacker will get redirected to the IDP and will log into the IDP, and you get a code, right? So remember the diagram we had, this code, authorization code flows to the browser. Now attacker can stop it, right? So attacker can stop this code being sent to the client application. It will extract out the code, not just the code, the complete URL, right? So now the authorization, the OAuth client never sees the authorization code, right, which is sent from the IDP. That request is blocked from the attacker, and you copy the complete URL, and somehow you send that URL to the victim. Maybe an email or somehow you send that request. Now victim clicks on that particular URL, right? So now victim's browser, so that particular URL is basically the callback URL pointing to the OAuth client along with the authorization code, right? So this will take you to the client application, right? And then the client application will talk to the identity provider's token endpoint and find out who the user is. Now the victim has logged into the web application, the client application, as the attacker. Right now, if we like add his credit card details or any other stuff, the attacker can also legitimately log into this particular web application and view all the details. Right. So this is a way of doing CSRF attack with OAuth 2. Now let's see how to prevent that. Right. The easiest way to prevent this is to use the state parameter. Right. So let's see how state parameter works. Right. So you saw that in Instagram use case too. State parameter is an optional parameter in OAuth spec, but it's something you must use because it adds a lot of value in security. Right. So let's see how state parameter works. So when the client redirects the user to the authorization server, it creates some random number. It can be random number, something meaningful thing. You create that number and add it to the state parameter, right? Into the request which is going from the OAuth client to the IDP. And it also adds that state parameter, the value of the state parameter, to the browser session. So in this case, browser means attacker's browser, right? So now the state parameter is attacker's browser, and it also in the request. Now it goes here. Then IDP has to send the same state parameter back to the callback URL, right? So now that state parameter is in the callback URL, which the attacker captures here, right? So now you send that callback URL with the state parameter to the victim. Now victim clicks on that. Now it will take the authorization server to the client application. Then client application will extract the state parameter from the request, which is a query parameter attached to the callback URL, and then we'll see whether that state parameter is also in the user's browser. In this case, that state parameter is not in the victim's browser, so the OAuth client can reject that request. So that's how you can prevent the CSRF attack from using the state parameter. Right? So there's another profile in OAuth called PXE, Proof Key for Code Exchange, that will also help you to prevent CSRF attacks. Okay? So there's a question: how mix-up can be possible when TLS was enforced for both token and authorized endpoints, HTTP header? Yes. So if you use TLS and it's guaranteed that TLS cannot be intercepted, you cannot do that. But once again, you know, like just by using TLS, we cannot take it granted that no one can intercept it, right? So there are many cases like Poodle attack. So many other TLS attacks happen in the past, right? So yes, so if it's a TLS strong, the attacker cannot do the mix-up attack. Okay? But one tier in security is you also go for multiple levels, right? So you would like totally rely on the TLS. Okay. So next, let's move into the implicit grant type. Once again, this is something you should not use, right? So implicit grant type has its own security issues, and OAuth working groups has officially announced that you should not be using implicit grant type. But I'll explain how it works. So here you you go to the client application, right? Try to access the client application. Then client application will redirect you to the authorized endpoint, right? And the request going to the authorized endpoint will have this response type parameter, right? So we remember we send the response type parameter always to the authorized endpoint. And the value of that authorized parameter is set as a token, right? So now authorization server, just like it did before with the authorization code grant type, it will ask the consent from the resource owner. So the resource owner will authenticate the authorization server. And then once the authentication is done, in step 2, user will be redirected back to the browser, to the client application with a token, right? There are no two phases here. In the first response itself, authorization server sends the token to the client application, and here you use URL fragment to pass the access token, right? So the specialty in the URL fragment is if anything in URL fragment, browser will not pass it back to the client application, right? So now you have the access token which came as a URL fragment. then the client can extract that out. So basically some JavaScript running in the browser can extract out the access token from the browser location bar. You pick it and then you use that access token to access the resource server, right? So this will be much clearer if you go through this sequence diagram, right? So you do a get to the client. This is browser, right? So no backend here, right? Then you will be redirected. So from the JavaScript itself, you will be redirected to the authorization server. Right? You send the response type as token. Now this will do the authentication of the end user, and then authorization server will redirect user to the browser. Right? You send the token access token as a URL fragment. Now the browser will it gets to the browser. Then browser will do a get to the client application, the web server, the backend of the application. In this get, you won't send this token. The token will remain in the browser. Then the client will respond back with a HTTP 200 with a JavaScript. Now you will still see the access token in the browser location bar. This script, JavaScript, will extract out the access token from the URL fragment. Then it can use that access token to access the API. Right. The issue here is, one issue is your access token is in the address bar. So anything in the address bar goes to the browser history. So anyone who is having access to the browser history can detect it. Also, since URLs get logged in some audit logs, there's a chance your access token gets logged in there as well. The most critical part is, let's say here you logged into the single page app, right? So most single page apps using used to use this approach before. Now you have your access token in the URL as a URL fragment. So you are on the SPA. Now when you click on some external link on the SPA, the URL fragment along with the complete URL on the address bar will go as a referrer header to the external application. So that means the external application will also get to know about your access token. So there's a token leakage. So that's why it's not recommended to use implicit grant type for any case, right? So even if you use single page applications, you need to use authorization code grant type with no client secret. So next week we'll talk about how to use OAuth 2.0 in securing single page applications, right? There's a question. Does IDP generate a new session for each client authorized request? How long that session should live? Yeah. No, IDP won't generate a new session. So if user doesn't have a session, if the first time the IDP sees a user, IDP will create a session, then that session will be maintained across all the other requests coming from different client applications. That's how you create this single sign-on experience, right? The session timeout, it depends on the IDP. It can be 30 minutes, 1 hour. It depends on the IDP. Most of the IDPs, that parameter is configurable. Okay. Next, the client credential grant type. So this is mostly used for system-to-system authentication, right? Here in the client credential grant type, we only have 3 actors. You have the authorization server, resource server, and the OAuth client. So you can think it a different way. The resource owner and the client both are the same entity, right? So there's no browser involved here. If you want to get a token, you have the client ID and client secret. It's not a must use client ID and client secret. You can even use MTLS or any other authentication mechanism of the client. So basically in step 1, the client will authenticate the authorization server and get a token, right? So that's the client credential grant type. Then the client can use that token to access the resource. So there's no on behalf of relationship here. So client directly accesses a resource just by being itself. Right? So this is mostly used by applications when they don't need to worry about the end user, right? From the resource point of view, they don't need to worry about the grant type. You simply expect a token in each request, right? Yeah, so this is how the client conditional grant type works. So from the client, it's a direct call, no browser, post to the authorized server. So here you can see the request goes to the token endpoint. So that means there's no response type. You only have the grant type, right? So now authorized server will issue a 200 with the token. So now the client has a token and it can use that token to access APIs. Password grant type, once again, this is something you should avoid using, right? This is in fact the same exact problem OAuth wanted to fix in first place, right? So here you have the OAuth client. The resource owner gives his credentials to the OAuth client, right? This can be a desktop application, mobile application, anything, right? Even a web app, anything. So the client will directly get the credentials from the resource owner, and then it will do HTTP GET to the authorization server. It's a direct HTTP request. It doesn't go to the browser. Send the username and password along with the client ID, client secret, or any way the client picks to authenticate itself. Then the authorization server will validate it and send the response back access token. Then the client can use that access token to access the APIs, right? So there are security loopholes here. You should avoid using that. So, but then again, like if this is the exact problem OAuth wanted to fix, why OAuth introduce this grant type, right? So this is in OAuth RFC. The reason is OAuth wanted to help the applications that were using basic codes for authentication to migrate to OAuth 2.0. So that's right. So if an application kept on asking username and password from a user, then they can continue with that, but still they can use the password grant type and can access an API which is protected with OAuth 2. So that's the only reason password grant type was introduced. This is something you should avoid using. Some people think when you develop native apps, you should use password grant type. That's not the right thing. Even for native apps, you should use the authorization code grant type. And then from the native app itself, you can spin up the system browser and do the OAuth 2.0 handshake and get the code. Then you exchange that code to an access token, right? So PIX is one standard, like a profile introduced by OAuth 2.0. So if you are using authorization code grant type for native apps, you must use PIX. But once again, for any application now, we recommend to use PIX, right, along with the authorization code grant type. Okay, so this is how the password grant type works. It's pretty straightforward. Once again, the grant type is set to password. This request goes to the token endpoint, not to the authorized endpoint, right? Okay, so we discussed about grant type. So grant type is a way that you can extend the OAuth flow. Grant type defines a flow how you can get an access token from an authorized server, right? You can do it in any way you want. Then scopes we discuss. Scope is a way to define or attach the purpose for an access token. Right? Then token types. It's another extension point in OAuth 2.0. So most of the OAuth implementations you see today, they use bearer token type. So, right? So bearer token is like cash. Like if I steal $10 from you, I can use that $10 at any Starbucks to buy a coffee. Right? So no one will ask whether for me to prove that I own that $10. Right? It's like cash. So if someone steals a bearer token, they can just use at anywhere to access the resources with that particular token. No one will question to prove the possession, right? So the other token type is called proof of possession token. So that means even you steal a token, you cannot use that. You need to prove that you own the token. It's like credit card, right? So if I steal your credit card, I won't still be able to use it without giving the same signature as yours, right? So proof of possession tokens are like credit cards, right? So that is why if you use bearer token, you must use that over TLS communication channel. Also, you need to do like other precautions too, right? Probably like if you are accessing an API, in addition to using TLS, you can also enable mutual TLS between the client and the resource server, or client and the API gateway. Once again, is an extension point. You can introduce other grant types too, other token types too. OAuth 2.0 map token is another token type, but it's not popular. Even the spec for a map token is still in its early stages. So there's a question. For native app, do we recommend to use native browser app or launch a separate browser instance which is outside of the app? How good it from you? Yeah. So the practice is, so I think you are talking about using the native browser, spin up outside your application, or else load the native browser as a web view to your application, right? So the recommended approach in terms of security is to use the native app outside your app. You simply like spin up the system browser, complete the flow, then you get the authorization code, then you exchange that authorization code to a token to the token endpoint of the authorization server. Right? So that's the recommended approach. You should not be using WebViews. Yeah. So in OAuth, we also talk about two types of clients. So one client is called the confidential clients. The other client is called public clients. Confidential clients are capable of securing their tokens, right? So for example, a web application is a confidential client. So it can protect the access tokens, client ID, client secret, those stuff, right? Single page application, it's a public client, right? So it's running on the browser, right? It's in the user, it's under the control of the user, end user can do anything. You cannot hide any credentials in an SPA, right? So SPAs are known as public clients. Even native apps, you cannot hide any credentials with native apps, right? So you can make it harder, but if the end user has this root access to the mobile device, whatever the things you hide, whatever the keys you hide, the end user can figure them out. So both the native apps, mobile native apps, single page apps, OLA, public clients, web applications are known as confidential clients. So OpenID Connect, we won't go into the details. We'll have another session to talk about OpenID Connect in detail. So you can think about OpenID Connect as an identity layer built on top of OAuth 2, right? So in addition to the access token, what you get at the end of the OAuth flow, you will also get an ID token. So that ID token will carry the identity attributes of the corresponding user. It's a JWT. So we talked about JWT in our very first meetup. So it's a JWT which presents set of assertions about the end user. So that's a layer of identity built on top of OAuth 2. Okay. So this is how OpenID Connect works. So this is basically the same diagram that I used for authorization code flow. So here in the first request, when you redirect the user from the client to the authorization server, you need to set the scope value as OpenID. Right? It's a must. If it's OpenID Connect, you must set the value of the scope to OpenID. You can have more scopes, but you must have OpenID there as a scope, right? So then authorization server knows it's an OpenID Connect request. It will send the authorization code here. Then in step 4, the client will exchange the code to an access token. Now, since the client knows this is an OpenID flow, the client will also return back an ID token in addition to the access token. So I haven't put it here. So in addition to access token, you will also get an ID token. Then you can use the ID token at the client side to find out who the user is. And if the client wants to access a resource on behalf of the user, then it can use the access token, right? Okay. Okay, I think we are running out of time. We only have 2 slides to cover. So this is another application of OAuth 2.0, like how we can extend the OAuth 2.0 grant types, right? So the SAML grant type comes into play when you have a service provider which supports SAML based login, right? So you have a SAML IDP, end user logs into the SAML IDP with SAML, and now the service provider has a SAML token, right, which represents the end user. Now, this particular application wants to access an API on behalf of the logged in user. How do you do that? Right? We cannot like authenticate the user. We cannot follow any of the other grant types. What you have is only SAML token, right? So what you can do is you can exchange this SAML token by talking to the token endpoint of the authorization server. You pass a SAML token and now you get an access token, right? Now to validate this SAML token sent from this service provider to this authorization server, this authorization server must trust the issuer of the SAML token, which is SAML IDP, right? So it can be done by validating the signature of the SAML token. If it is fine, you issue an access token, then the flow is the same. You use that access token to access the API. Then authorization server will talk to the authorization server. The resource server will talk to the authorization server to validate the token. Then authorization server knows all about that particular token, who the client is, who the user is, everything. Right? Same thing can be done with OpenID Connect. So this is a typo. It has to be an OpenID Connect service provider. Here, instead of the SAML token, what you get is a ID token, which is a JWT. Here you can follow the JWT grant type RFC to exchange this JWT and get an access token. So once again, to accept this JWT as a valid token, the OAuth authorization server has to trust the JWT issuer or the OpenID Connect provider. Okay. One important thing I need to mention. So when you get a token from the authorization server, an access token, it can be a self-contained token or else a reference token, right? So self-contained token means a JWT, right? So if it is a reference token, resource server has to talk to the token issuer to validate that token, which is just an opaque string, right? But if it's a JWT, authorization server doesn't need to talk to the the resource server doesn't need to talk to the authorization server to validate it. It can validate the token by itself with JWT. It carries a set of claims, and you can validate the signature of the JWT in a self-contained manner, right? And that's not a problem. Some people get confused this concept, right? So now, if you can have a JWT as an access token, then people question, why do we need another ID token in OpenID Connect flow? If you can pass JWT and access token, then why not you include all the user details in that access token as well without sending a separate ID token, right? So there's a key differentiator here, right? So if you take an ID token, which is JWT, the audience of that ID token is this client, right? So in the ID token, there's an element called audience that should match the audience value of this particular client, right? You should never send that ID token to the resource server. But when it comes to an access token, even it's a JWT, the audience of that JWT or the access token is not the client, it's the API, right? So that's the core difference between a self-contained access token and an ID token that you get in an OpenID Connect flow. Okay, so we'll discuss OpenID Connect later. So there are multiple flows in OpenID Connect. So we'll go in detail to each of those flows later. And then there are a couple of questions. SAML and SiteMinder session ID are both having same flow. Yeah, so SiteMinder is once again, it has a proxy and IDP. So that's an implementation of the OpenID SAML flow. But then again, when the SiteMinder proxy intercepts the request, right? It talks to the IDP, authenticates, then it creates its own proprietary channel between the proxy and the application, right? So SiteMinder session ID is some proprietary identifier used in SiteMinder implementation. Okay, so that's what I plan to cover. If you have any questions, we can discuss this at this time. Okay, if you have any questions, you can just unmute and speak up as well. Okay, then thank you very much for joining. So next week, we are going to have a meetup on securing single page apps with OAuth 2.0. Hope you will join that. And also, if you go to the meetup site, you can see a link to a Slack channel. That's a IAM for Developer Slack channel. You can join that too. And if you want to discuss anything, any questions about this session or any other stuff, you can discuss there. Thank you very much for attending. Thank you very much, and stay safe. Thank you.